Hi everyone. Thanks for the introduction, Alberto. I'm Christos Karamanolis. I'm sure you can remember my last name, so call me Christos. And I'm going to be talking about vSAN. I'm the architect for vSAN, so
it's all your fault?
Oh, it's all my fault, yes,
okay.
Absolutely. So
signing blame is very important.
yes, you can blame me for everything. Beyond vSAN, I've been with VMware for almost 10 years now, so you can blame me for things that came before vSAN as well. I don't know. No, that was a statement. Perhaps it doesn't.
Don't say that.
Totally hold back on that.
I'll take that back. Forget about that.
We absolve you from everything before vSAN.
Yes, right. That's correct. So for the next about hour and a half, I'm planning to do two things. The first hour, walk you through some of the architectural decisions we made when we designed vSAN, and we tried to address the market we had in mind. And hopefully by the end of that, I'll convince you that we made the best architectural choices or reasonable architectural choices within the constraints and the context we had. And in the second part, I'm going to focus more specifically to the new version of vSAN 6.0 that is actually about to ship. I believe that, practically speaking, is shipping today.
Today.
So yeah, so there you are. So I'll start with the main goals we set to ourselves when we started on vSAN about 4.5 years ago. From the very beginning, our main objective was to build a product, a storage product that is really suited for our existing VMware, vSphere specifically, customers, and make all the choices that are really targeted to make those customers really happy and provide them a compelling product. And by compelling, I mean a very good total cost of ownership that consists of two parts. First, CAPEX, provide really low cost, usable storage capacity, but even more importantly, really affordable performance. And in virtualized environments where you have a lot of multiplexing of the workloads, we're talking mostly about random workloads and where IOPS are what count. So really cheap IOs per second. The second aspect of that is make it very easy to manage, the operational aspect. So what we want to do is really piggyback on the existing management procedures and workflows that our customers are familiar with and they use day to day on their virtualized infrastructures. So in other words, we set off to build the software-defined storage for virtualized environments, for vSphere environments. And of course, our goal, first and foremost, was to integrate the product with all the existing products and features that VMware ships and provide the same operational experience to our customers so that they have easy adoption. So before I go into the architecture, just a couple of comments. I feel that based on the initial experience we see with the product in the market for almost 10 months now, then the amount of adoption we have is at least justifies that we got some of those goals right. We have 1,200 plus customers at this point. Got some trophies. I'm not going to brag about those, but really this is what I care about. This is an actual picture from a customer's parking lot in Southern California. Darn, I should have that plate. So it's very, very exciting.
It's not mine.
It's not his. No, it's not his. That has been confirmed.
It's not mine.
This guy clearly hates his storage
Empire.
So
Another question.
you said 1,200 customers. I know about a month or so ago it was about 1,100 customers. Has it actually surged by about 100 in the last month or so?
I'll confirm and deny.
I accept that. If you cannot confirm or deny, but I know it was Duncan had said like an official-ish, like 1,100 paying customers for vSAN.
The official number is 1,000 plus, but yeah, it's growing.
Sure.
Yeah.
No.
And that is
1,000 over 10 months.
That's significant.
That's about 100 a month.
And actually, this slide I took from our partner exchange presentation. Mm-hmm. So that is the data as of then.
Yes.
Correct?
Right.
Yeah.
So it should be.
Let's leave it on that.
Even if it's not accelerating, it should be about 1,200.
Yeah.
What is the average size of the cluster?
Of the cluster for vSAN deployments, currently the customers are doing, of course, they're mostly testing the product. So the average cluster sizes on the smaller side. Okay, do you have any specific data?
3 and 4.
Well, so they
4 is
start
about
with
the
3
same.
and 4, and then it depends.
Depends on the deployment and application. They
and
go
we
up to 8.
We have customers that have actually huge deployments.
deployments, yeah.
And we have customers that the big numbers are actually small classes, and we have even some returning customers, right?
It's a very bimodal distribution. When you look at it, we have large customers deploying already large sizes, and then small customers deploying small sizes. So the average falls
there's
in the
the
middle.
small ones who are being careful and the large ones who are being really adventurous, and we haven't filled the middle in yet.
Exactly.
Yeah.
If you think about it, an average vSphere customer, an average vSphere cluster is around 8 to 10. So that's what that average.
8 to 10 ESX hosts?
Yeah.
Is that? And then how much capacity are you controlling or managing?
That depends on the case. There's
Oh,
so
no,
much
that
variability.
8 to
It's
10 was the
difficult to comment.
vSphere cluster. The vSAN clusters are smaller.
8 to 10 existing vSphere customers. And our average is like 4 to 6 for vSAN customers. All right, let's move on into some of the technical stuff now. So the question is, how did we go ahead to address those goals I outlined briefly to you guys? So I'm going to go through a number, I think 8, of architectural principles we applied. Starting from our decision to go with a hyper-converged infrastructure. So the idea here, and actually when we came up with the original architecture, the term was not even coined back then, but anyway, it still means the same thing. So the goal was to streamline the procurement, deployment, and the operations that our customers apply to manage their infrastructure, including now with our product, storage. So so we went with a hyper-converged infrastructure so that because our customers were asking explicitly to provide them a solution where they can grow in tandem their compute and storage resources in their clusters in the data centers in a way that is non-intrusive to the existing data center network architectures and allows them to use same kind of management principles that they use for compute, CPU, memory, and even networking so far. So what we did is we developed a distributed software product with software running on every host, every ESX hypervisor in a cluster. All hosts play the same roles in the system. They aggregate the local storage resources, flash and magnetic disk, depending on the configuration, and they make them all appear as a single virtual data store that is accessible by all the hosts in the cluster. There are no special roles in the software. There are no gateways. There are no metadata servers. There are no protocol access points that would introduce any bottleneck. And you'll see more about these things in the rest of the presentation. Very scalable, hyper-converged architecture. Now, being VMware, we own the most popular hypervisor in the market, right? ESXi and vSphere in general. So we saw opportunities in the overlap between the hypervisor and the storage. So specifically, we decided to build this product as an integrated part of the hypervisor. And why so? Because the hypervisor has, first of all, a visibility into applications and VMs that external storage typically does not. We know of the individual VMs, the VMDKs, the workload that goes on every single VMDK and its behavior, as opposed to traditional storage systems where you have a big data store, a LAN or a few LANs, where tens or hundreds of VMs reside. So what the storage is like a washing machine situation with all the workloads of the different VMs interleaving there. So moreover, the hypervisor manages all the resources of the applications. It manages the CPU, the memory, does scheduling for networking, does scheduling for storage. And so if you include in there the management of the storage resources that the applications require to meet the quality of service, you can have a very effective solution. You can have a very efficient solution doing it that way. So specifically, we took this idea a step further, and we decided to put some of the critical paths of the storage product actually in the ESX kernel. And I don't want to overblow this. In fact, we make this thing, and to be honest, for us engineers, it would have been much more convenient to do a development in a virtual appliance model. However, this approach has some critical advantages. So first of all, what did we put in the kernel? With two things. Not everything, just two critical parts. First, the clustering service. The service that detects the liveness or failure of hosts and network connections. Being in the kernel, we can take advantage of the specific low-level scheduling principles we have in the kernel to be very aggressive with failure detection. That, in combination with a transaction logging on the host that participate in transaction, results in very good performance, especially for the right part of the workload. And because we can afford to make even aggressive failure detection, and false positives are not such a big deal. We can always very efficiently and fast recover from them using the log structures, and we can talk more about that. The second part we put in the kernel is the data path. Here we're talking about the protocols that send the operations across the cluster to the storage. These are the distributed protocols that implement our RAID protocols to distribute transactions and so on.
Do you have like a caching layer that's sitting in the kernel, or where's the caching?
I'm going to talk explicitly about caching because I know this is a very interesting topic. I have an entire section actually dedicated to that. So I'll be happy to take a lot of questions there. So let me outline here the high-level things, and then we are going to be drilling now into the details of every single thing. We do caching. The caching is managed by a module in the kernel, and we are going to talk about the principles, the specific principles.
Memory that's allocated to the cache is part of the vSAN?
No, we're not talking about, in the general case, we're not do in-memory caching, with a couple of exceptions which I'm going to talk about. And the exceptions include in-memory caching for certain workloads that can benefit a lot from that, like virtual desktops, and for our new vSAN sparse snapshots. Right. So where was the data path? So the idea here is that you can really optimize properties like the latency because you don't go through two stacks, the ESX and the virtual appliance stack. But most important for that, this is a decision we made because of that goal I mentioned earlier, that we really want to offer very cheap performance. And one of the most fundamental parameters for that is the CPU cycles you consume for every single I/O that your workloads issue. And putting this in the kernel, we can really minimize those CPU cycles per I/O per second. That is fundamental. So why this is important? Exactly because of this, and this is actually numbers from vSAN 5.5. Even though we run vSAN, a software product, on the hypervisor, we have minimal impact, if any at all, to the consolidation ratios that our customers can achieve. Exactly because the very few resources, both CPU and memory, our storage stack consumes. So we have this example here with a VDI deployment where we have vSAN, which is the blue bars, versus running the same fully populated 8 hosts or 7 hosts with virtual desktops against an all-flash array. And as you see, we have a small drop of whatever that is, about 5% in the number of virtual desktops we can run on the host because when vSAN runs there. Yeah.
So the vSAN cluster is all flash as well, or?
No, this is 5.5 where we do not support all flash, so that is a hybrid cluster.
So it's an all-flash storage system, standalone storage system?
The disk array we compare against is an all-flash disk array. What I'm saying is not that we are utilizing the full disk array. That's actually a big monster. That's something we use for our own internal testing and qualification. It's a big monster. I do not claim that we saturated this external disk array. What I say here is much more specific. I say that we can achieve virtually the same consolidation ratios for virtual desktops, as we have with an external array, while we run the vSAN full stack for the full, what is this? This is a view benchmark, right, Rollison? While we run a full virtual desktop benchmark on these 8 node clusters.
Right, but the data for that benchmark was
On
smaller than the flash layer in the vSAN, right?
The active working set in that case was yes, small, fit
So
in the task.
So this is a comparison of I/O overhead, not
Correct.
raw, not overall performance.
In fact, really, yes, very good observation.
Nailed it.
Yes, exactly, because that's where we used the most CPU cycles, right? Full blast using the flash to our disposal. Yeah.
So you're saying minimal CPU consumption and memory consumption, but actually you are only making copies of data, which is by default you don't use CPU and memory to do that. Most of the storage solution out there today do write of some kind, do compression, deduplication, and whatever to optimize space and sometimes IOPS. So, and they use most of the CPU
a fair point, but here what I'm comparing is against a storage that doesn't really do anything else but storing data.
Yeah, but in 2015,
so as we introduce,
it's hard to find something that doesn't do that kind of stuff to be at least efficient, especially if they are hybrid, because they need to have a fair cost, gigabyte for dollar cost, and even more in old flash.
Yeah,
so now you are
absolutely
supporting old flash with vSAN.
I'm not. That is a very valid point. I'm not making an absolute statement. I'm saying that when you run your protocols, when you have them you implement in a way that do not cross 2 storage stacks, full storage stacks, because ESX has its own full storage stack, right? The PSA stack, and say a virtual appliance with a full Linux storage stack and the virtualization that is involved in that. So what I'm saying is, relatively speaking, going through a single storage stack as opposed to 2 storage stacks, we consume relatively fewer CPU cycles. So whatever we do it with fewer CPU cycles. We do not do deduplication at this point. We do RAID protocols, and our RAID protocols are generic, and we have now RAID 1 and RAID 0 and RAID 1 over 0, and in the future we may have more of those. And CPU is used for that. CPU is used for doing distributed transactions. So people have many concerns about scalability of distributed transactions, and we use minimal CPU for that. And I'll show you guys data later on to make some scalability arguments about vSAN. Yeah.
So I mean that. Back to the benchmark prior chart, you were actually running the VDI view benchmark at the same time you were doing vSAN in the 7-node cluster and the 8-node cluster?
Yeah, of course, because that benchmark produces I/O, which is served by vSAN at this very same time. Yes. All right. So we move to the next one, which is actually a little related to this discussion about it's about protocols. So what we observe is obviously, in this product, in this hyper-converged product that is integrated with our hypervisor, ESXi is both the producer and consumer of data, right? As you asked, we are running now workloads, and that there are hosts in the same cluster are generating the workload because of the VMs that run on those very hosts, and the same hosts actually also serve the workload using this distributed software product, right? So we're both the client and the server, if you wish, in this storage system. So what we decided to do is have a protocol that is optimized for this specific use case. So what we do is we have layered our architecture, our data protocol in 3 roles. One is the client. That is, for every VMDK, the host where the VM runs acts as the client for accessing the object. the object that stores the VMDK, and we'll talk more about objects in a few minutes. So we have the client, then we have the coordinator. This is the logical entity that coordinates the access to the data of the VMDK that are distributed in the cluster. It is the metadata server for that specific VMDK, and it's also the guy who coordinates the transactions across the cluster. So, and then we have what we call the data servers. Those are the hosts that store the data for the specific VMDK, whether those are the replicas or are the stripes of replicas and so on. So what we did, first of all, is we, in the most common cases, we co-locate the client role with the coordinator role. So the host where the VM runs is the coordinator for all the storage of that VM. What that means that now the client, that host, can talk directly to the host in the cluster that store the data of the VMDKs, of the VMs on that host. That means that we save ourselves one network hop to an ingress point to a storage system, which is the case with traditional storage systems, like a nice SCSI or NFS, where you go from the host to some ingress to a cluster storage system, and then the data, the transactions are performed within the cluster from that ingress point. So one less network hop. Also, we have implemented overall our protocol stack very well integrated with the network and storage stack of ESX, and we have specifically developed a reliable data transfer protocol, which is essentially exports a network agnostic interface to the layers above. Today, internally, we use TCP for our communications and the data transfers, but the protocol is RDMA friendly, so in the future, whenever RDMA becomes eventually commonplace, we could switch to that,
Okay,
for example.
So what exactly are we talking about with RDMA friendly? That you'll run on top of iWarp and take advantage of TCP doing the error correction then? Or are you talking about running something like Rocky where you're going to have to now build your own reliability in because you don't have TCP IP to rely on?
The former, initially, but the latter is also an option. But
Okay.
that is the order I would do things. Yes,
It
well
certainly would
spotted.
be the,
Yes.
the path of least resistance.
Exactly, absolutely, yes. And actually,
have-
RDT has some fault tolerance features. We do multipathing,
Right.
so that's one feature we do, right? And we do a lot of buffer management and things like that. But if we do not do the TCP level kind of
Packet loss recovery.
Packet loss recovery, exactly right. Yes.
So I have a minor but bone to pick with this whole argument. Because 3 years ago, I got a white paper from VMware saying you should run your SQL server as a virtual machine because the overhead of running up and down through the stack is completely negligible and you shouldn't worry about it.
Yeah.
And now VMware, the same people who told me that, are telling me that the overhead up and down the stack is really important and I should care about it, especially since when I run a VSA, I use VM direct path and the RAID controller is completely owned by that VM and the storage isn't going through there anyway.
So we are not changing our position. But
You're refining it very fine.
Yes, I know we're working a fine line.
7 nines pure.
So, which is why I said I don't want to overblow this.
Yeah, I think we all need to. I think we all need to
the
settle
argument-
on the proof of the pudding is in the eating,
Yeah.
and that the quality of the code will matter more than whether it's in the kernel or not. That a good VSA will be faster than a bad kernel module.
So let me make one argument here. And so scheduling, our ESX schedulers, CPU schedulers, and everything are generic schedulers, are really tuned for application, and it took us 10 years to tune them initially for our initial application targets, then for a database and so on. They are not necessarily tuned for the best possible way for storage stacks and I/O going serve for other applications. So there is one part of that. So for vSAN specifically, we did not use the generic scheduler. We built our protocol, our data path around I'll give a little bit of detail here. Wordlets, which are execution context in bottom halves, because we could do much more predictable I/O.
I can
delivered.
buy completely that
So
that you
I
have more
understand
control over
for-
the schedule at the kernel.
Right. For the big crowds out there, those are fine print details that they don't care.
This
for
is
us,
Tech Field Day. We like fine print.
Sorry.
This is Tech Field Day. We like fine print.
Okay. Good. So
We got magnifying glasses and everything.
So we spend really a lot of engineering effort to fine tune some of that internal scheduling. I'm sure other vendors that work in virtual appliance, they do their own fine tuning at that level. Everybody does it at the level where they can and they're most comfortable with, and we are very comfortable with our schedule. So for us, and this is not a comparison, we managed to really bring down considerably the cost of I/O CPU cycles by fine tuning our schedules and our storage stack and network stack to really make them fine-tuned for storage workloads that we generate and implement these protocols. Is that the first statement?
Yeah.
All right.
Just
So Christoph, why wouldn't you have used like iSCSI or something like that rather than generating your
Aha.
transport protocol?
You see? Yes. Very good question. So we actually, our first prototype used, I'm not going to say which protocol, but a public, a standard open protocol. But then we start playing with these things and we went down the path of optimizing more and more and more. And we had much more leverage to do that. Things like what I described, like we have my client and my metadata server, reminds you of PNFS a little bit, right? On the same host, right? Where the data access. Moreover, it gives me the flexibility to do this metadata service in a much more distributed fashion, doing it for every single object, every single VMDK, and I distribute this metadata service role across the entire cluster. It was because of some of those observations we went with this proprietary, if you wish, protocol internal between the ESX host. Now, if I wanted to provide access to vSAN storage to entities that are not ESX hosts, if I want to use them natively from within VMs, guest operating systems, or even outside a vSphere cluster, what would I do? In that case, I would go obviously with a standard protocol, and that is all customer demand. And believe me, we are ready for that demand when it arises. We're working on that. So very, very good insight there. Yes.
So help paint this picture for us. The point on the slide is protocol agnostic. So now it's running over TCP/IP. Mm-hmm. Why even make that a point? What's the future use case other than TCP isn't going anywhere? Is it to run over a different type of network?
Yes. So that's why I made the argument about RDMA. And also, I cannot disclose publicly some of the information because it depends on information we get from our partners in a confidential fashion. So as but we always looking down the road, right? And we see potential because nobody knows for sure, evolution of the network architectures and protocols in direction that will make these cluster software-based storage systems, much more efficient to use new technologies that are coming. So we have this abstraction layer. So down the road, as an engineer, I don't want to go and build everything from scratch because the protocol abstractions change, right? So I want to have an abstraction. This is really what I'm disclosing to you is some of our internal kind of convenience approaches. So
that matters a lot more to you than it does
yes,
to us.
Yeah. So
yes.
from a kind of future roadmap perspective, if you look at a cluster and inter-cluster communications, and as we get deeper down this hyper-converged rabbit hole, and the communication with the inter-node communication for the cluster may not always be TCP. It may be something that's much more efficient than
Correct.
TCP.
That's exactly a good way to summarize it. Yes, absolutely. Yeah.
So Christos, let me try to close here. So you are mentally, or not emotionally, but your development team is prepared to, at some point in the future, roll out a standard protocol for vSAN when the demand exists.
If and when it exists.
If and when it exists.
You know, the product marketing guys, I'm going to kill me, literally. This guy's going after me if I make any more specific statement. You see why it's holding there and rolling his thumbs.
They blame me if
You're safe from Rollison because Chuck said he's not paying for damages.
No, like the Rollison is like, he's rooting. Yeah, tell them more. But yes, yes, I think it's fair to say that. If and when that demand occurs, we would be ready for that. Yes, and we hear we listen now to customers, and we have a big enough customer base already who are interested. We spend a lot of time. Actually, I personally spend a lot of time talking to them about our roadmap and getting feedback, and a lot of these things will depend on that. So, in fact, even some of our partners. And Rollison will talk more about that later, asking that very question. Mm-hmm. So,
but from a customer delivery point of view, first of all, you guys use a custom protocol, and accessing that custom protocol cost me $5,000 MSRP per host because I have 2 CPUs per host, and I have to buy a vSAN license to access the data, even if I'm not going to use that to provide data because I got plenty of performance. Second, I still have some physical servers. And so from a customer point of view, there may be performance advantages to your solution, and I'll grant you that, but there's cost and complication disadvantages that I have to face as a customer.
You sound awfully like a customer I talked to yesterday, a very big customer. Yes, absolutely. They made the exact same 2 arguments. Yes. So we listen to that, and we are not dogmatic about any of that, right? For now, what we said is let's focus on our main target, which is get these guys running their VMs on vSphere and our vSphere clusters to have a really cost-competitive, efficient solution, simple solution. Let's start from there. That serves this purpose. Now there are many more use cases. Actually, not even the traditional storage protocols that you guys are I believe, alluding to, like NFS versions and iSCSI, but even more use cases. And he's looking at me, so I cannot really tell more about that.
I'm a bad guy.
Yeah, well, we're not going to get into PNFS because
No, I'm not talking about PNFS. Even though I have been a co-author of one proposal to extend PNFS to help with some of these things, but I'm not talking about PNFS.
So, would you say that 5.5 was a precursor to like a vVol implementation? I mean, is a vVol implemented in vSAN today, or how does that play out?
That's a 1 hour worth of conversation.
Yeah.
Let me cover it in 20 seconds, and we can talk more about that towards the end of the presentation. vSAN, I would dare say we spend a big fraction of our time as an engineering team here in VMware restructuring ESX and our storage control plane, starting from our user space libraries. People like you may have heard about DiskClip. We introduced a whole new layer of managing and controlling object-based storage, and all the vModel APIs and all the control plane that is involved with that. And that was built with what? Object-oriented storage in mind. And I will talk in a few minutes about the details of that. vSAN is one implementation, one data plane for that object-oriented control plane we have. And vVols is now the open interfaces to that control plane for our partners. So the upper half of vSAN, the control plane, is exactly the same as vVols. It has been designed like that from the get-go. Another interesting part is that why an object? Why keep I talking about these objects like as if these are, by the way, these are not like S3 objects. This is, I don't know if some of you are familiar with the NASD work that was done back in CMU in the 90s. That was after your time at MIT, but I think one of the guys was...
There was some overlap.
There was some overlap. That's why I'm looking at you. I know that, yes.
Yeah.
So it's essentially big chunks of data with self-contained, with their metadata and all the information you need to do, that you can distribute efficiently and everything. They are not file systems. That is what it is, right? So why I keep insisting on these subjects? I'll give again 10 seconds because I want to talk more of that if we move ahead and have the time. Because I want to expose different data abstractions on top of that. Virtual SCSI disk is only one of them. I want to be able to offer either through us ourselves or through partners file services. I don't know, Hadoop protocols. We already do a lot of these things for our own metadata. We have a cluster file system, VMFS, on top of those objects. So you'll see about that. So it's a 3-layer cake. It's the control plane, which is object-oriented. It's the data plane, which we have our own vSAN, and we have vVols now. And then there is the upper layer, which has a great opportunity for us and for partners to innovate on top of the object platform. And we'll talk more about that. Yeah. So you were asking about caching. So I'll start talking a little bit about that. So first of all, our fundamental decision was to use a 2-tier approach for our storage. Essentially, what we see is that we have workloads in virtualized environments that are in aggregate, random, where in the general case, IOPS are on the smaller side. I think the average size is about 4K or something like that. And with high consolidation ratios, which are typical in our production environments, you see like what you see, the I/O that is coming down to the storage is really very random, high IOPS workload. So what can we do to serve really efficiently that workload? What we saw is that, what we know is that magnetic disks, which are the common thing we still most of us and our customers think about when we think about storage and capacity specifically, they're increasingly getting cheaper and cheaper in terms of the capacity they offer. We now have like enterprise grade SAS disks which have are like 5 cents per gigabyte or even less sometimes, right? But if you think about their performance, even some of the best 10K, 15K RPM SAS disks, they offer like a handful of IOPS operations per second, like 100, 200, right? Fair. So if you do the division of dollars per IOPS, those IOPS are seriously expensive. They are a few dollars per IOP per second, right? So they're not good for those random workloads we have in virtualized environments. So what do? Well, Flash. Flash, still capacity is relatively expensive, right? It's going down, but relatively speaking, it's one order of magnitude more expensive than magnetic disk. However, those devices can get you hundreds of thousands, sometimes IOPS. Do the division of those couple of $1,000 over the 100,000 IOPS you get. The IOPS cost nothing, right? Less than a cent per IOPS.
Right. Most expensive in dollars per gigabyte, least expensive in dollars per hour.
Exactly right. So we say, well, let's combine the best of both worlds. We're going to have a flash-based tier for caching, so that essentially we get the vast majority of our performance out of these flash devices that are really provide us with really cheap performance. And then let's get a capacity tier in the back, which provide the storage for the data because they have really cheap capacity. So what we do what we did in the first version of the product 5.5 was to use the flash tier for both read caching and write buffering. And read caching, we used the default is 70% of the devices. And actually, before I even go into that, just to clarify something, because I have this question often. We organize storage on hosts in what we call disk groups. A disk group is one flash device, SSD or PCIe device, with one or more magnetic disks behind that. If you wish, this is our storage fault domain, okay? And we can have multiple of such disk groups on each host. We can have up to 5 disk groups, and each group can have only one SSD and up to 7 magnetic disks in 5.5, and we'll talk more about all flash later on. So so it needs this group. That flash device is the cache tier of this group, and 70% of it is read cache, 30% of it is write buffer. What do I mean by write buffer? This is very important here. Magnetic disks are really crappy in terms of random I/O.
No.
But they are very good with sequential I/O, right? So what we do is we accumulate writes in our write back buffer in the SSD, and then we destage them. We have an elevator algorithm that destages them on the magnetic disk behind that SSD in a way which is really friendly for magnetic disks. We essentially destage for every magnetic disk big batches of what we call proximal I/Os. They don't have to be perfectly sequential, they have to be proximal, because all modern magnetic disks have this property where they can quickly, they can be very efficient in writing the data as long as we are within a window of cylinders. So they don't have to be perfectly sequential. So we destage sequential I/O. So essentially the workload that our magnetic disks see is a proximal I/O workload, really ideal for them.
So it's not quite a log structure.
We have a log structure file system in our SSDs. And that is in order to really have, actually, you are one step ahead of me always.
Damn it, Howard.
Didn't he warn you about that?
5%.
So we use a log structure on this format for the SSDs in order to have a benign workload for the SSDs. The SSDs do not like writing here and filling a page and then deleting something in the middle, because then they go and resolve things and you have a write amplification. So what we do, we have a log. We write things, we fill up pages, and then we destage things and only when we know that all the data that are on a page have been destaged, we say, okay, we free the entire page. So the SSDs hardly have to do any write, any data reshuffling themselves. So we really minimize the write amplification aspects, and that's why we are confident that the endurance of SSDs under our product is going to be by at least as good, if not much better, than what the vendors advertise out there, because the vendors advertise, the numbers that advertise of endurance are with not necessarily such ideal workloads.
No, but they're also very conservative.
Yeah, they are conservative, yes. And some of these statements are made, we have verified with every single SSD vendor, and we have vetted our protocol with every single flash vendor out there. Yeah. So.
But you're saying that you're using on the disk is not a log structure file, but a proximal I/O. And can you define what you mean by proximal I/O? So you're writing blocks within a certain number of cylinders. Is that?
Yes. Yeah. So we have our own file system on this format, if you wish, for the magnetic disk, which is different than the one we have on the flash devices. Yeah. In 5.5, we had a local version of VMFS L, right. And VMFS was never designed really with local disks in mind, right? But for us, again, being engineers, we try to reduce things, and we have to, we need to focus on a distributed. So we took VMFS, we pared it down, we removed the clustering features. It's a very, very mature and stable product, right? So we use that in version 1. In version 2, and I'll talk more about that later on, we use the file system we obtained from the Virsto acquisition.
So that's a real log structured file system.
We do not use the log, actually it has two parts. It has a log and has a very nice, actually,
so you're using the back end.
Yes, so we use the back end. In fact, we don't use the log. So it's,
really?
That is something, I know many people think otherwise, but we did not use the log of them, because when we sat down with Serge, we said, oh crap, you guys, your log structure file system is identical to ours. Right. Because how many
you already solved that problem.
We solved that problem. So our main problem, and again, you're ahead of me, is how to get really a very efficient, sparse format, data structures that can allow us to build data services on top of that, starting from snapshots. I'm going to talk about that, but not only snapshots. And
Christos, I have to warn you,
yes?
Virsto presented at Tech Field Day.
Okay. All right, cool. So let me move on. I know we are kind of falling behind a little bit.
That's all my fault.
No, it's not. I really enjoy this. So I have a tendency to stick on things that I enjoy talking about, like this, all these proximal things and stuff like that. So it's my fault. So let me try to move a little. This is another of my favorite topics.
Here goes another half hour.
When I thought we would be moving fast. Okay, so this is a very, I know it's a topic has been discussed, tweeted. This guy has published articles. He has jumped up and down on stages. So let's settle this thing here. How do we do caching? In vSAN, and that goes back to your earlier question, we do distributed caching. We have, and I'm talking about a persistent cache. This is what I was telling you about caching in SSDs for performance, meeting our performance goals and a performance efficiency and low cost. These caches live in front of the magnetic disks on every single host where the data are stored. We do no persistent caching on the client, on the host where the VM and the VMDKs run and are accessed. Why do we did that? We just didn't randomly decide that. It was something we agonized over for a long time. So, and here's why we did it, because this approach gives us the best way to make the most utilization out of our expensive flash capacity around the cluster. We want to be able to distribute and use as much of those and as efficiently those flash devices for caching as possible. So bear with me for a second. What are typical network latencies in 10 gig networks today? Sorry?
Milliseconds.
In 10G networks, it's a microseconds, right? Mm-hmm. I mean, at least on our networks here, I see anything from 5 microseconds.
On the internet on your
Sorry?
That's wireless. That's wireless.
No, but
the people they like on.
Yeah, in my lab on the 10 gig network, it's like 500 microseconds.
What?
I got old switches.
Okay.
Yeah.
But in my test infrastructure, and I cannot tell what switches I have here, right? No. In my test infrastructure, I see.
You have a bigger budget.
Think big.
Yes, yeah. In my infrastructure, I see anything from 10 to 50, sometimes 70 microseconds.
10 gig.
Sorry?
Yeah.
10 gig, yes. With some of the well-known, and actually we have multiple vendors. With all of them
with a
consistent.
switch like an Arista, you'll get that.
Yes.
Such with a C.
Yes. No, we have some of those too.
Yeah.
I mean, we have lots.
But
So
a test is not often a production environment where existing resources stand. Therefore, if you set the commonality at the 500 to 1 millisecond range, at least you'll say, no matter what, I'm always going to be within the ranks of an average enterprise.
Fair enough. But what I'm referring to is actually production environment. I'm talking about our internal cloud, which consists of a few thousand ESX hosts where we run all the testing of all VMware products, and which runs actually on vSAN now. So I will have I know it's not typical of production environments of some of our customers, but it's production environments where we run.
It's probably typical of a greenfield today.
Yes.
Something somebody was going to buy today.
Perhaps. Even though there has been some legacy in there, right? We are an old company.
So while we're talking about the latencies, the point on the slide there, is that flash latencies are 100 times larger or 100 times smaller?
Larger. So let me make my argument. So let's take a number of 50 microseconds for network latency. Now for or 20 to 50, whatever. So for flash devices, if you see the specs, they say, oh yeah, depending reads or writes, tens of microseconds. But that's when you send one IO at a time. If you look at the specs of some of the most popular and actually good devices, like the S3700, right, from Intel, you see that they say 99th percentile of IO with a queue depth of 32 are served within 1 millisecond. And I can tell you, and we have verified this with vendors, that is very, when you run those devices under load, the latencies are very close to that. Very close to that. They're talking about operating ranges in the 7 to 1,000 microseconds. And even the big guns, like the much faster devices, like the P3700, if you see the spec, says 99th percentile, 750 microseconds. So adding like 20, 30 microseconds to 1 millisecond is in the noise. I mean, I have more variation in my network than that. So, and in our environments, we really drive those devices hard. We have maximum queue depth, so we can get the maximum IOPS out of them, right? So,
if I add a couple microseconds to every IOP, no one's going to notice that for a single IOP.
So
you're doing a million IOPs. Those microseconds add up really fast.
The micro in aggregate, but those IOPS are each VM and each application has a reasonable parallelism in it, right? So in the system, when we deliver and you see like a million IOPS, right, in a Mondes cluster, those don't come from one VM, right? So they're distributed. So the point was, it's more important for us to really make good utilization of those expensive flash devices in the cluster because of this. So that's why we did distributed clustering. Does local distributed caching? Does local caching matter? Of course it does. It matters when your cache material, a device, has latencies that are much lower than your network, right? So today that is mostly RAM. And actually we use RAM-based caching, in fact using a deduplicated RAM caching, which we actually support today on for our VDI use cases, because virtual desktop has such huge overlap of blocks that is extremely, a few tenths of megabytes or 100 megabytes can take you a long way in terms of efficiency.
Of blocks repeat a large number of times.
A lot, yes. Now, down the road, we are very much aware through our partners that new technologies will be emerging and new protocols will be emerging that will reduce the latency of persistent storage.
Trying hard not to
it's
get
hard to navigate this.
So
this
Christos
thing.
is not saying that we're going to support MRAM or NVDIMMs, but he is implying that that might be a good idea.
You
in the
said
future.
that, so that's cool.
Yes,
I said that so he didn't have to.
When devices with very low latencies, which remain low under sustained workloads, are there, which going to be sometime not in the so distant future, it makes a lot of sense, and we'll have the technology and we'll support those things when it's the time to do that.
Okay. Would it be fair to say that you consider flash resources more expensive than network resources and are therefore spending network resources to save flash?
Yes, to some extent you can say that.
In a typical read operation that is random, so it's coming off of disk the first time, you're going to bring it into memory from the disk and then write it back out to flash, so it's now cached on the flash layer. Is that how this works?
We do not have in-memory data caching, and with exception.
So you bring it into memory transiently.
Yes,
and
right.
We
put it on the flash.
Transiently
Yes.
until it's physically on flash. But
Correct.
you are reading it from the disk and writing it to the flash for every original read that comes
Correct.
down.
And we have our cache line size is 1 megabyte. And
you're
that
reading
is
a megabyte of disk for any block that's randomly read.
we access a
writing
block.
that megabyte to the flash
Yes.
in a log structured fashion.
Correct, exactly right, yes. And why 1 megabyte? Because it's a good trade-off between keeping our in-memory metadata in a reasonable size versus having, we have seen we spend many months doing analysis of actual customer workloads, and we saw that there is, for the customers we are targeting at least, there is a lot of locality of reference, spatial and temporal. So that 1 megabyte was a good trade-off to good memory utilization and serving data from due to locality of reference from the cache after you access the first time.
During write operations, you're accumulating at least a megabyte, or you're accumulating even more than that because you're doing a log block.
I'm not going to say the exact number because there are some heuristics for which I don't want to go into, but accumulate lots of stuff, yes.
A lot more than just a megabyte, and writing that in one
sequential way, yes.
Yeah, to the flash.
No, for the writes, when we write something, so let me talk a little bit about that. Writes, say we have 2 replicas for a VMDK. when the guest OS does one write, the operation goes to the local client/coordinator I was talking about, and then it's sent concurrently to both replicas. One may be local or both may be remote, doesn't matter. So we send it to both the replicas. It's persisted on the flash, and only then we acknowledge back to the coordinator, who acknowledges back to the guest OS. So when the write completes to the guest, the data that's been just written are fully compliant with the protection level the customer has asked.
And that data means that if it's persistent, it's written to flash.
To flash.
In a log structured fashion.
Correct. Yes.
And the log stripe is somewhat bigger than a megabyte.
I'm not going to comment on the details of that.
It may or may not be bigger than a megabyte.
It does not have to be bigger than a megabyte.
May or may not be bigger than a breadbasket.
That is an implementation detail.
So if it were not just 2 copies and it was 3 copies or more based upon whatever
All
the
of them.
specification is, it does this simultaneous write to all of those.
Exactly right, yes. Except if, of course, somebody is detected to be offline because there is a network problem or something, in which case we still have to write to a quorum.
Yes.
Okay?
So a minimum of the amount that is prescribed.
Yes, correct, yes.
You would think this would be a challenge for your write operation performance, because you would have to physically write it to the SSD before you could respond back to the host VM that said that your operation is complete.
What would be the alternative with commodity hardware? Some disk arrays have battery-backed NVRAM. That is not commodity, right? We use commodity components. So the best we can use in that case today is flash devices, right? So, and despite that, you'll see you have seen already some numbers. You'll see more today. In fact, you'll be the first people to see some of our 6.0 numbers today. Our performance is really good. I mean, performance is nothing to worry about, including write performance.
And then because each, and I'll call it server, can have different streams of write activity going to it, because it could be a replica for one and the original for another.
Yes.
The performance is not, you're going to have to wait until the worst case write occurs for the quorum.
Mm-hmm. Yeah, that is right. But in this kind of environments we have in data centers, the networking behavior is not. It doesn't deviate
networking
much.
as much as being able to write the stripe to SSD. I mean, if you're having to accumulate more than, the block that I'm writing, you're going to have to wait more than the time.
We write aggressively. Now we are in danger of going into too many implementation details, but we do have a small in-memory buffer where we accumulate multiple writes, and then we flash them all together to
You won't actually record the fact that you completed the write.
So of course we never acknowledge the write unless it goes to the flash. But because in very high sustained IOPS environments, within a matter of microseconds often we can accumulate enough writes to flash them all together as one record on our log. And I'll leave it at that. So I don't want to. I don't want to go into the really gory details of that, because those are implementation, which may even change over time, right? As we tune them. Actually, those algorithms are very dynamic, and they are tuned to the behavior of the underlying system. So, both in the lab and with real customers, even customers that do some very high performance analytics which are very heavy oriented, that's not a problem. Compared to external disk arrays, no comparison.
Well, on the subject of writing aggressively, you guys talk about using...
Well, what I meant by writing aggressively, just to clarify, is that we don't wait for like a few milliseconds before we flash to the SSD, right?
I'm simply taking the term aggressively to go someplace else. You guys talk about using commodity hardware. The vast majority of the other folks in the hyper-converged world use low-end disk controllers and 7200 RPM drives so that I can get very high data density within the server. And you guys have had some problems with lower quality backend, and I have to buy 10K RPM drives to run vSAN, which means I get a 1.2 terabyte drive, not a 6 terabyte drive.
It's I have an entire slide dedicated on what I call the colossal task of being a real software storage platform, and doing all the qualification for with all the partners out there. So let's save that question for that part, because it's
sure, no, if it's coming, fair enough.
All right. So some of the benefits of this distributed caching is that VM mobility doesn't really affect your performance. You don't have to transfer gigabytes of data from one host to the other host when your VM is vMotion. And the majority of our customers actually use DRS, and DRS moves VMs around. And that's the whole point of having a virtualized environment, right? You want to take your host down for maintenance, your VMs move out of there. So you don't have to necessarily be moving terabytes of locally cached data because of that. So here is one graph that I stole from Rollinson about vMotions, and here we have two vMotion from at this point in time, and then again to that point in time, between hosts that have not even a local replica for the data, and you see no glitch whatsoever in the performance here. Okay, so let me talk briefly about this object stuff. I already talked a little bit, so I'll go really quick in this subsection, so that we have time for more discussions, including some of the software-defined challenges and so on. I already talked about this vision, right? What are objects? Why we go that path? The effort we put into building a really object-oriented control plane in vSphere, and how that is utilized for vVols. What I would like to show you is this picture here. We present in more detail how an object-based storage system like vSAN is used in ESX. This diagram applies exactly the same way from that part up to vVols as well. So what we're talking about here, there is no cluster file system as we understand it in traditional storage systems. So vSAN actually does not even know anything about VMs and VMDKs. vSAN also only provides objects. Those are chunks of data, anything from a 1 gigabyte, whatever, up to in version 1 was 2 terabytes. Sorry, version 5.5 was 2 terabytes. In version 6.0 is 64 terabytes. 62 terabytes. Usable, yes. Yeah. So now what do we do? How do we store the state of a VM in a vSphere? First of all, we create one object here it is, within which we create a VMFS clustered file system, the vanilla VMFS you guys know of. And then that is in a subname space, a directory under VMFS volume vSAN data store. We create a subdirectory called foo. We mount, in this case, that VMFS volume that has been created for this VM specifically under its own namespace, the name of the VM. It has actually a friendly namespace, which is a link to a UUID-based namespace, okay? So this is a fully fleshed VMFS, and I stress that because you'll see why in a minute. Then, for each of the VMDKs of the VM, we create another object. So each VMDK has its own object. And we reference those objects from within the VMFS file system by using some small file descriptors that contain the UUID through which the vSAN can identify and access the object that contains the VMDK. So actually we use objects for other things. For example, the swap of the VM, or now in 6.0 the memory checkpoint if you want to create one of the VM. And even more, and I'll talk more about that, every single Delta disk for our snapshots, the legacy redo log based and the new vSAN sparse. So everything is a separate object. This is important for a number of reasons. First of all, vSAN enforces policies including quality of service, availability, things like that, at the granularity of individual object. So each of your VMDKs can have a different underlying policy. So your database, for example, may have a high replication policy, perhaps multiple stripes for performance reasons, things like that. And you may have also a VMDK which is crash space or temp space that you don't even care whether it is replicated or not. So you pay in terms of storage only for the things you need and only those. Okay. Also, this approach has another big advantage in terms of scalability. How many of you know, I'm sure many of you know about the scalability problems due to locking we had traditionally in VMFS, right?
Oh, really?
What?
Never heard of them.
Right. So,
Little tiny.
what was the problem? The more VMs you put in a single data store, the more log contention you have, right? So, and that we result as making all those crazy white papers that we have written over time, say, oh yeah, you could put a lot of VMs, but don't put too many of them, right? And here's some guidance.
One LUN per VM.
Right. No.
Oh, yeah.
And then yes.
I didn't say
It works in a 10 VM environment.
And I had a customer
customer
showing me the spreadsheet he was maintaining. It was like mind-boggling, keeping track of exactly that, right? A lot of those things are based on exactly that feedback. So here, any log contention on this VMFS is related only to this VM. When does that happen? In those rare occasions that VMs have to access from different hosts. When the VM is vMotion or when there is an HA failover. So, and the contention is only for this VM, not for all the VMs in the cluster. So, that's it. There are no scalability concerns. VMFS is good enough. Yeah, it uses a little bit, a few hundreds of megabytes for space there for its metadata, but in the modern world, like that's not it's such a big deal. So, scalability is a big advantage.
You just said, and I quote, there are no scalability concerns, right?
For VMFS here, yeah.
For VMFS here, but for vSAN, there is a max object count we have to account for.
Yeah.
That's growing over time, but
yes.
we reach a scalability concern until the next time we move the peg and it becomes a new
here
scalability.
I'm talking about VMFS, and we'll talk about scale of vSAN. Yes, in version 5.5 we supported up to 100 VMs per host, and that was a soft number depending on the constraint we had of 3,000 objects per host. Now we have grown that in 6.0 by 3x. And this is really, essentially the metadata overhead, right, in the system. And
but now that you have usable snapshots, the object count is going to grow substantially.
Yes, and we understand that. Yes.
And that matters to us in the room as customers, partners, etc.
I totally understand.
We want to make sure that it will scale with our use, because on a regular basis, any clustered file system or any file system we interact with, one or more of us has broken those systems based upon just what we try to do is maintaining our business.
Yes, totally fair point.
Yeah. And we want to make sure this doesn't break and flourishes.
We go to this 3x number because that was a nice round number, and we could just focus our system testing on something that was reasonable.
Right, and it's unlikely before 6.x next version comes out that people will exceed that. So
yes, absolutely. Yes.
So now you're just running ahead.
Yes. And so the plan is to always be ahead of the needs. Yes, but that's absolutely fair point. Yes, I totally see that. And believe me, because we use vSAN for our own production, right, and we have probably the biggest environments of vSAN that exist out there. We are very, as the users of the system, we're also very aware and we understand the problems. Yes.
So your phone occasionally rings. Christos, what's going on?
Right.
Much as I hate the term, I'm glad to see you eating your own dog food.
Yeah. Oh, that is our mantra.
Pedigree up in here. That's how we do it. Let's just note with the finest stuff.
And even hands-on labs at VMware we run on vSAN, right? And I have actually, if we have time, I have a nice anecdote story from hands-on labs that I will share with you guys.
Were you running all of VMware production on your 5.5 vSAN instance?
No, we do not run all the VMware production because, as I said, VMware is an old company, so we aim for greenfield, and actually we build also the biggest is our own internal R&D test cloud. that is where we dog food.
You did say all of your VMware cloud, but now you just said R&D test cloud, just because unless both of them are running on it, in which case that's great, but those are two potentially different things.
Actually, I don't even know exactly what is the rest of the cloud.
I think he's more implying that the corporate ERP system doesn't necessarily run on vSAN yet.
Like legacy stuff, but a lot of our clouds, things are running.
I can tell you for certainly that our R&D cloud, which is what I mentioned before, the thousands of hosts and everything, that runs on vSAN. And of course, we have other storage systems as well, mostly because we test and qualify and all these things. Yeah. About the corporate IT, I'm not the right person to answer. I know we have some. I know I talk with some of these guys, but I don't know what percentage runs. I don't know.
Sure. Within VMware, vSAN is everywhere. Put it that way. It's everywhere in pieces, chunks.
Whatever this guy says.
Even though I'm sure you get a nice discount from EMC.
More than a discount.
What?
Yes.
We get a bro deal.
Storage is cheap here.
We get a bro deal, basically.
Let me talk a little bit about manageability, because this is the unsung hero in all this conversation around vSAN and integration with the hypervisor. That's why I said, actually, I don't want to really, I want to put more emphasis to this as opposed to all these kernel conversations and things, because those are really esoteric things, and I see them more as engineering decisions, right? For guys that really want to tweak the low-level things and squeeze the last CPU cycle out of those.
Agreed, except that they're also marketing messages, and we have to make you defend the marketing message.
So absolutely, yes, and you are doing the right thing. So, but let me talk about these things, because I don't think we talk enough about this, and I think it's very important, and I'm very proud on behalf of the engineering team about some of the achievements here. Very early in the game, I had some very crazy ideas about this, dominating world, right? These huge clusters that, screw vSphere clusters, we're going to do our own thing, we're going to scale, do federations, do things like that. No relation with the other federation, okay? So actually, has any of you guys played with the product? Have you installed? Have you seen any of the log messages from CMMDS, the clustering service, where it refers to the cluster as a sub-cluster? Mm-hmm. Everybody asks me about that. I say, oh yeah, that's it reflects some of our original goals and still ambitions of doing some crazy stuff, right?
I have dealt with enough crazy customers that I know that there are demands for, well, we want it to be one vSphere cluster, but this group paid for that set of disk drives, and they don't want those guys to share these disk drives with them, so why can't I have 4 data stores instead of 1 data store?
Yeah, there are lots of people want to have one big data. The vast majority of the people, I'll tell you what they told us up front, and then we can go to the outliers.
The IT guys want one data store because it's easier to manage,
yes.
And the business units have their own crazy ideas because they don't know what we do.
You remember what I said at the beginning? You know who is our main customers we target initially? Are not the storage guys, which are the disk arrays guys.
No,
I know you guys are storage guys, many of you, right?
Get targeted the virtualization guys who hate the storage guys, because now you can get them to not have to deal with each other.
You nail it. You know what? We empower those guys and say, "Oh man, finally, I can be control of my own fate." So,
but I have a bone to pick with that.
All right.
Because we are storage guys and we are paranoid.
Yes, absolutely.
And we are paranoid because we have real enemies. Every storage guy I know has had not the, oh my God, I made a mistake, I might lose my job moment, but the, oh my God, I made a mistake, I may have put the company out of business moment.
Yes.
The virtualization guys have never had that. And they're
understand.
a little cavalier by comparison to us crazy people.
That's a fair statement, and actually, the sensible guys. We talk with a lot of customers, and in the vast majority of the cases, here's the scenario: we walk in the room, there are 3-4 virtualization or infrastructure guys, and then there is this big guy sitting in the back of the room like this, who is the storage guy.
That's me.
Who is actually looking over the shoulder of the kids, right? So that's exactly the scenario, and in fact. When we get into the details, obviously I enjoy the conversation with the big guy in the back of the room, but the customers that have the immediate needs, that this guy admits in most of the cases that he cannot really meet the demands. These guys are crazy. They want me to provision a LAN, 4 times a day. It's like this is not a sustainable model. So the discussers are okay for those workloads. Okay, I'll make sure they do the right thing. Give them something that they don't bother me, right? So we go after those guys with collaborating with the expert, right?
Right.
Whenever
I just see too many cases where there won't be that adult supervision, and you guys defaulted to failures to tolerate equals 1, and somebody's going to go, oh, I need to upgrade the memory on this server. Let me put it in maintenance mode and vMotion all of the VMs off of it, and put it in maintenance mode, not realizing that he's now running storage with 0 resiliency.
But you have to see it from the other perspective, right? There are many customers out there that do not even have the luxury of having the big storage guy. What do we do with them?
My argument is, you guys should have set failures to tolerate equal 2 as the default.
Okay.
Which means you have to re-architect your quorum so that if I have 3 hosts, I don't need a separate witness and I can use all 3 of them for storage, because 3 is a special number in this case. Because now to do FTT equals 2, I need 5 nodes, and 5 nodes is bigger than $1 billion company's entire IT structure.
But I'll take an issue with one of your comments here, because my background is academic, so I want to get all the correctness of the protocols always right. So when we have 3 nodes and we have 3 replicas, I can never safely, unless I involve human intervention, and humans tend to screw up things, I can continue from only one of the copy. Because I don't know what happens with the other 2 copies. They may be up and running in the other part of my network partition.
No, but if I have 3 nodes, and I can't have a split brain. As long as I have 2 of the 3, I should continue to run. I shouldn't need 5.
When did you know that? When you were on the
2 can see each other.
But you can tolerate only 1 failure. You're talking about tolerating 2 failures.
But if I have 3 nodes, no witness, I can tolerate 1 failure and continue to have resiliency.
Yes, but that is.
And now I either get to choose to tolerate 2 failures and continue to have resiliency, but require a minimum of $25,000 in software licenses, or I can choose to have 1 failure and no resiliency. That middle ground is a very valuable place that you're not letting me go.
I'll take that as input, and because you're always 1 step ahead of me,
Continuously.
Look what I have in the next slide. So I'll come to that of some of this part of what you're pointing in this slide. So let me make a quick comment here. So at some point we became like really focused and said, okay, what do exactly our customers tell us? So the vast majority of the customers, admittedly, the mostly virtualization guys, they need to manage their storage in ways they feel familiar with. They say, guys, what I want is this storage thing you're talking about, this data store. I don't know exactly what you're going to do, how you're going to do that, but make that a part of my cluster, because I have all these established management workflows and principles and scripts often around this kind of organizing my infrastructure in the form of cluster. So make vSAN a property of the cluster, so it's much easier for me. Please do not introduce yet another management concept, yet another storage management tools to manage your storage. It's VMware should be integrated with the basic concept you have there. Also, they say, don't make me re-architect my data center network. And most of them say, do not even dare replicate across my beyond my, what they call them usually pods or SARs, which is like anything from 1 to 4 racks, which are fully interconnected, fully provisioned network. And outside that, you have different topologies, but usually oversubscribed spines, right, to go across the network. So they say, do not even dare do synchronous replication RAID over oversubscribed network. So contain my data within my data stores, within my clusters. That's how I use even my disk arrays today. So don't make me change my network topology. So what we decided to do is to make, and this is not an architectural fundamental requirement of the product, but it was a product management decision to make the vSAN cluster to be the same as a vSphere cluster, to make these things much easier. That allows for very good integration with the management workflows that our customers already know, and with some of the features, and I'm going to talk about this, like DRS, HA, things like that. And management workflows, I'll start from the cornerstone of management in vSphere clusters, which is maintenance mode. That's what customers use every day, right? You want to do a hardware or software upgrade, you want to decommission a host, all these things. So traditionally, DRS would kick in if you want to put a host into maintenance mode, migrate the VMs out of it, be done with it, right?
VMs are small.
Right, and HA had to know about not start new VMs there, things like that. Now that host contains data that are maybe critical for the availability of your application, right? What you are saying. So say I had a disk fail, right, or a host fail, and I missed that little detail, and now I want to put this host into maintenance mode to upgrade it. What do I do? What do we do about the data? Existing solutions, including hyper-converged solutions, they don't have that kind of integration. They find about a host going into maintenance mode after the fact, and that is essentially equivalent to a failure to them. If there was another real failure, the customer may be screwed. So what we do here, we expose the user the options they have to their disposal according to what their intentions are. So if you really have a suspicion or that something else may be going wrong, or if really you want to take this host down for a prolonged period of time, of perhaps a few hours, you want to make sure that you are not going to in any way sacrifice the data availability and reliability in your system. So what you say is, I want to ensure accessibility of all my VMs, including those that have data here. So if there is something like a copy is not quite right, or something is rebuilding because of an earlier failure that happened yesterday by still building all those terabytes of data, we know all these things and are going to transfer the data, and just those data that are necessary to make sure that everything will continue going smoothly, and all your policies, availability, failures to tolerate, will remain to still be satisfied after this host goes into maintenance mode.
And ensure accessibility is the default, right?
Yes, it's the default, correct. And now, if you know that your host is going down to be decommissioned, and say, okay, now actually really migrate all the data of this guy and distribute it in the remainder of the cluster. This kind of integration is what I'm talking about. Another integration is with HA. So I'm sure many of you are getting familiar with this, right? And this guy has written so many papers that I don't know if it has helped or not, but so HA is a complex monster, right? It's a complex monster because it has to deal with every weird failure scenario and combination of failures you can imagine or you cannot imagine. So traditionally, our HA product made an assumption that the storage area network is independent of the management network among your servers, which HA used traditionally, and actually even more reliable. So storage was used for many purposes by HA, for heart beating between hosts, for storing HA metadata information, and it was an assumption that even if there is a partition in the cluster, even if there's a host going away, all those hosts, despite the partition in the vSphere network, are still going to access the same storage. Well, guess what? When you have a clustered, distributed software system, not only vSAN, but any of these hyper-converged platforms, that assumption is not true anymore. When your cluster partitions, your storage also partitions. So what do we do in that case, right? So here's another advantage of that object-based approach we followed in vSAN. If a partition happens in a vSAN cluster, all partitions are allowed to coexist. We don't pull the plug on the hosts that are in a minority partition or anything like that. What we do is on a per VM basis, we make a determination on which partition that the VM has quorum of its objects, of its data. And if it has in one partition, the right partition, we let it go on there. If it has quorum in the left partition, we let it go on there. In at most one partition. Some unfortunate cases, they may have one VMDK may have quorum here and one VMDK quorum there, so in that case we cannot really do anything. But you understand the idea. We enforce quorum and at most once semantics at the granularity of VM, improving overall availability. So how does 8SA deal with that? So 8SA has been modified to accommodate these new semantics that vSAN brings on the table. And we spend actually a lot of time, and we make sure that not a lot of code, but it was a lot of effort to get all the scenarios dealt with correctly. So whenever is, and I'll explain things with some simple examples. Here is, we have one host, host 1 in our case, where a VM runs with a VMDK that has 2 replicas and a witness, and this host goes down, right? So the 8SA agents that run on the rest of the host, they have to decide first of all what to do with this situation that they detect the host go down, the same way they detect today. One important thing here is that when 8SA and vSAN are both enabled on a cluster, 8SA does not anymore use the management network for its agents to communicate with each other. It uses the vSAN network. And why is that? Because those are 2 different networks. Typically, we use a 10 gig network for vSAN and 1 gig network for your management. So the partition behaviors can be different. So that will result in utter confusion. So 8SA uses the vSAN network, so the partitions between the storage and the 8SA cluster are identical. So when a host goes down, both vSAN sees the host is down and has a whole lot of workflow of deciding what to do with that, which I'm not going to talk about here. But 8SA also detects that host failure. And so 8SA does what? It says, okay, I need to see if there's any VMs running on that host. The 8SA agents maintain a list of all the 8SA protected VMs. Starts from there and says that there is this specific VM running on that host. What the 8SA does now is every agent goes to the master, the agents elect always a master. And to be precise, a master in the partition of the host that can talk to each other. So the master in this partition looks at this check, in this list, says, oh, this VM needs to be restarted. And what it does, it says, is this VM accessible from this host? And if it is accessible, which means has quorum of its data, as it is the case here, restarts the VM. Now, the more interesting scenario is this one, where we have a split brain situation, where the cluster is split in the middle, right? So all the hosts are up. Just these 2 hosts cannot talk to those 2 hosts. Now, 8SA runs here, 8SA runs there. And there's an 8SA master here, doesn't matter in either of those hosts, and the same on that partition. Those masters now have to make independent but consistent decisions, right? So the master of this host say, oh, partition, I cannot, or I suspect partition, I cannot talk to those hosts, they're isolated. I have a VM here that is 8SA protected. This VM actually does not have access to its quorum the data. So what vSAN does, it does not allow any I/O from this guy. I/O is frozen. So eventually 8SA will see that and will kill this VM. And this guy, the master here, also sees that has no quorum. The VM is not accessible, so it does not do anything about it. It does not even try to restart it on any of the hosts in this partition. So on the other partition, the master there looks at this, oh, I have isolated hosts. Some VMs were running with that. Oh, there is a VM was running on one of those hosts. What do I do with that guy who's protected? He checks here and says, oh, this VM is accessible here. It has quorum of its objects. So it will restart the VM here. You see now, these 2 guys have made independent decisions without being able to talk to each other, but because vSAN guarantees this quorum per VM on the storage layer and enforces it, we ensure that the VM is started on the partition where it has the quorum of its data.
So
Any questions?
When a 3-level protection, fault tolerance, then there would be potentially 2 VMDKs and a VMDK and a witness split. Is that how you would, that could potentially happen there?
So these are what we call here VMDKs, are the 2 replicas of the same VMDK.
Yeah, so
right?
I have another replica and a 3-way replication, right? So one would have 2 replicas and one would have a replica and a witness. What's the decision?
As long as you have quorum, and the quorum is defined on the configuration of your replication. So you have 3 replicas, then you have 2 witnesses, then you have to have 3 out of those 5 entities to have quorum.
Oh, so you have 2 witnesses and a 3 replicas.
Yes.
That's why you need to have 5 nodes, which is what I was complaining about.
You could have more than 2 witnesses too, because it's dependent where the data is placed.
Yes. I'm simplifying this a little bit because each replica may itself be striped. It may be striped because you asked for that. For example, actually we didn't talk about that, but when do you specify stripes for your objects? Because when you know that you have an interesting workload, I wouldn't say it peculiar, an interesting workload like a database, right? Which has database logs are sweet things because they have very good locality of reference, very, very good to deal with. But the tables, those are big monsters, sometimes of hundreds of gigabytes, if not more, which are accessed in a completely random way. They're the worst things one can try to cache, right? So your cache is not going to be very effective, except if you have very big caches. And we actually providing documentation, will be providing more documentation, actually good automated tools down the road to help the customers do the sizing. But say that your caches are not big enough to accommodate that database. What you want is for the IOs to that database are going to be served by the spindles. So you want to put for that VMDK of that database more spindles behind that, so those spindles can handle the IO that escapes from the cache. So you ask for striping for that specific VMDK. And that goes back to my point that your policies are tuned to really what you need for each of your virtual disks, right? So back to this point, it's not just a replica. So one replica may have multiple stripes, either because you ask or because we decide to do striping to load balance the data better, or because your VMDK is getting really big and we need to spread it out. So if you ask for stripes, the stripes you get will be at least as many, okay? So because of that, our quorum algorithms are more complex than what I described here in a simple way, but the principles are the same. We're going to be introducing witnesses so they can always form quorum when you have at least one full copy of your data and you have enough witnesses to vote for that guy. Make sense? So I guess I need to move a little faster.
Damn right.
Steven? Yes.
We locked the door, they can't go away.
Yes, that's another thing. So I'm going to go very briefly over all the management monitoring troubleshooting very quickly. We're providing, first of all, one thing that people do not realize how important it is for customers, and actually sometimes even VMware does not realize, is that a big percentage of our customers have their own automation tools, scripts, software that use our APIs, vModel APIs, and SDK. So with vSAN, all the vSAN functionality, all the features are all controllable through Vim APIs, through vModel APIs. Exact same APIs our customers know and use currently. It can be used also to configure, manage, control, introspect your storage state, and do that from a VM-centric way. And beyond APIs, you provide a number of tools in 5.5, admittedly a combination of relatively simple tools, from CLI commands to our RVC, the Ruby vSphere console, which is a Ruby-based management tool, which is extensible, can call the vModel APIs to its associated vSender server, and is extensible, so are extremely popular with customers who write their own kind of workflows and things in Ruby. And also have the vSAN Observer, which allows to have a holistic view of how your system performs and behaves, both from perspective of the physical resources, how is that SSD used? How is those magnetic disks used? What about CPU and memory consumption? Or from a VM perspective, okay, let me see how my VM is doing, what performance it does, IOPS, latencies. Latencies are high. Why? So, okay, let's see, this VMDK has high latency because it seems to be contending for this with this other VM on this SSD, or perhaps this SSD seems to be on its knees because it gets much more load than it was designed for, things like that. And down the road, we're going to provide much more sophisticated tools for this, and this guy does not allow me to talk about them, even though they're going to be released pretty soon, right?
Yes.
What is it? Come on, Howard, you know what it is.
I ain't saying.
You could say it because it's not us.
Signed an NDA. I'm not.
I'm just checking because you're always ahead.
Software. So we claim we are going to be the only real software product. Unlike other vendors that ship appliances, we are going to give to our customers, if they want, the ability to have an a la carte choice of their hardware, and we're going to support every hardware. Those are very brave words.
Really a glutton for punishment, aren't you?
Oh man, yes, I'm a bit of a masochist, I guess. But this is a colossal task. It's bigger than what I had anticipated. So vSAN supports everything on the ESX server HCL. But on top of that, you understand we're not offering storage ourselves in the past, right? So we are certified some controllers and HBAs and so on. But here now we're talking about certifying, but from the perspective of us being the providers of storage, anything from controllers and the 1 million variations of firmware and settings of them, which you have one controller hardware platform from a vendor, and then like a few thousands of variations from the different OEMs, not only per OEM, but from server platform kind of version of each OEM. It's crazy. So, but anyway, we have the resources, and we're very motivated to really do this. We have a very sophisticated certification suite, which by itself, it's like a product. I'm not exaggerating. So we qualify controllers with all their settings, flash devices, both SSDs and PCIe, and magnetic disks. So we have, I don't even know what are the current numbers, but we have like hundreds of controllers, many hundreds of devices. So
yeah, but they're all variants of the same LSI.
Yes, but believe me, I made that statement. Oh yeah, we can. No, no, you have to qualify them.
Did learn about
and
that,
some of the
you?
issues you mentioned, it was because of some of those assumptions we made. Qualifying the same controller, even with the same settings of one vendor, and saying, or let's say LSI, and assuming that will work with the same family that some of the OEMs use. No, there are some tiny but often critical firmware changes that people do not even know exactly what they are.
I'm
difference.
sure you call the OEM and they go, all we did was change the copyright. Mm-hmm. But it acts differently anyway.
Or they don't, it's more complex than that sometimes, but yes, that's the spirit, exactly. Or so, yeah, we had this, we had some requirements that were implemented by the hardware vendor, but we don't know exactly how they were implemented because the implementation could make a difference. So we had to go back to the other guys. Anyway, so of course we offer pre-qualified end-to-end ready nodes, and last but not least, the traditional bundle, right, with everything software and hardware together in the form of Evo Rail, in the future Evo Rack appliances.